going to be discussing optimization, and specifically, we are going to be looking at optimization um, as it pertains to quadratic functions or quadratic models. So, what exactly is a quadratic model? A quadratic model is anything that can be written, or any situation modeled by a quadratic formula. Okay, there are really two things that we end up needing, because when we're talking about optimization, we have really two ways we can go. We can either go with a min-max type situation, maximum profits, maximum height, minimum cost, uh, anything of that nature. But if we're looking at a minimum or a maximum, what we really need, as far as our function is concerned, is we need to know the vertex. The other situation that we can have is a situation where we need to answer the question, how far did it travel? This comes up a lot in physics. So, how far did an object travel? Another question that would be answered the same way as this one would be, when do we break even? So, the break even point. But regardless of which one of these we're actually talking about, we're referring to the same thing. Both of these are done by looking at the intercepts. So we're either going to be looking for the vertex or we're going to be looking for the intercepts. Let's look at one involving maximizing area. So let's say we have 2,000 yards of fencing. And we want to enclose a rectangular field. Okay. And the thing is, when we enclose this rectangular field, we want to have the maximum area. So with maximum area. So this is one way that we can have information presented to us. We want to know the dimensions of this field. So at this point, I honestly recommend drawing a picture, because drawing a picture might help us get a feel for exactly what's going on. Okay, so we have our field set up here. Now, we need to know a couple of things. We really need to consider length and width, and we need to be able to find those in terms of each other. Why do we need these two values? Well, the area of a rectangle is just its length times its width. To find one of these values in terms of the other, is where this 2,000 comes into play. Because we know that the perimeter, which is 2 length plus 2 width, this perimeter must equal 2,000. So what we have here is 2,000 is equal to twice the length plus twice the width. And if we solve this, we end up with, let's say we solve for our width. So if we solve for our width, we end up with 1,000 minus length is equal to width. So what we have just done is we've written this width in terms of length. We now know that this equals 1,000 minus our length. Well, how does that help us really? It helps us like this. Because we know the area is length times width, we now know that the area of this is equal to the length times 1,000 minus the length, because length times width, which means that our area is equal to 1,000 times our length minus our length squared. This is a quadratic model. It's written in standard form currently. We have the area in terms of our length is equal to negative L squared plus 1,000 L. We don't have to rewrite it like this. I'm just doing so that we see it is in standard form. We want to know the vertex because we want to know the maximum possible area. So when we find the vertex, we use the H formula. So how we find our H. We can either complete the square, or we can just find our H using the fact that we know H is going to equal opposite B over 2 times A, which in our case is negative 1,000 over 2 times negative 1, which is a positive 500. Now, this 500 is the H coordinate of our vertex. This 500 is a length value. So we know that this is 500. Now we can find the width. The width is 1,000 minus 500, which is just 500. So the type of pin, the type of rectangular pin that gives us the best area is actually a square. A square that is 500 yards by 500 yards. If we wanted to know what is the maximum area, is, instead of just what the dimensions are, we can take this 500 and plug it into our area formula. So area with respect to 500 is going to equal negative 500 squared plus 1,000 times 500. Okay. Well, if we calculate this out, we end up with 250,000 square yards. So if we build a fence that is 500 by 500 yards wide, then we will have 250,000 square yards of space inside of it. You could have also multiplied these together. 500 times 500 gives us this. So, what we have here is we're going to be given things verbally, and we have to come up with an equation. And that takes some practice, admittedly. You have to get used to reading things and working with it from there. One formula that does come about in this is the amount of, if we're talking about economics for a second, the revenue of a function of a product, we'll call this R, is equal to the product of a variable x times p, and this p is representing the price in dollars. So price. X in this equation is representing the number of units sold. So units and price. Generally speaking, we'd be able to figure out the value of the price and use that to help us write an equation that is quadratic, and then we solve that equation. However, the big thing to note with these questions is think about how the equation is formed. You can get this by understanding that it's a revenue problem. If it's a revenue problem, you would just use that. If it's an area problem, drawing a diagram of the shape that we're looking at so that we have an object that we're trying to find the area of. So it could be knowing the formulas. It could be drawing a diagram. There are a lot of different ways to go about setting up these questions. That will do it for this video, and I will see you